Well, now we're ready for 5.5, which is Newton's second law, which is really one of the most famous equations in all of physics. I actually don't know what the result of a pole would be if you put down E equals mc squared and F equals ma, which would be the more famous equation. 5.5 is F equals ma. And of course, we kind of gave it away because in 5.4, we already brought up the idea, at least, that for component by component, fx is equal to max. Because we argued that there was this proportional thing here, so that if you doubled the mass, you got half the acceleration. Or if you doubled the force but kept m the same, you got twice the acceleration. So we'd already basically written it down. Now we're writing it down in its full vector form. And let's actually be careful here now. You see, when you write F equals ma, you might go, well, okay, you had a child on a sled, and the child had a few different forces. The child had a normal force, the child had a gravitational force, and the child had a static frictional force. So we had all three of those acting on the child, and you might go, well, which one of those goes in here? What goes in here is actually F net, okay? Which you can also say is F total. Those are synonymous. F total is equal to F net. You add up all the forces on an object. So in this case, where there's three of them, we've got F sub g, which is a vector in the downward direction. We've got F sub static, which is a vector in the horizontal direction. And we've got n, which is a vector in the vertical direction. And you add those up vectorially, and you've got F net. It is F net that goes on the left-hand side of the F equals ma equation. So you add all those vectors up vectorially. If you're trying to find the acceleration, then you divide through by m, and you find out a, in this case, for the child. You find the acceleration of the child. Interestingly, you do not find the velocity of the child, you do not find the position of the child. What you learn from this equation is the acceleration of the child. Then you have more work to do. Work that we've done back in the previous chapters that tell you how to get change in velocity from acceleration or change in position from velocity. So that's it. 5.5 is actually an incredibly short section. It's an incredibly short section because you did 4 chapters and 4 more sections leading up to 5.5. Now we just have to learn how to apply it.